All right, welcome to Chapter 3, where we're going to begin looking at designing studies. In this section, we're going to take a look at samples and surveys. All right, so in this section, you will be able to identify the population in a sample in a survey, understand the difference between a voluntary response sample and a convenience sample, describe how to use a table of random digits to select a simple random sample or an SRS, describe simple random samples, stratified random samples, and cluster samples. Try to say that 10 times fast, and explain how undercoverage, non-response, and question wording can lead to bias in a sample survey. Okay, so by the end of this unit, you will be able to answer the following questions. So do students learn better when they're listening to music or in silence? Do SAT scores really go up if students attend a 6-week SAT seminar? Do students learn better when they're sitting in rows or in a horseshoe pattern? And do students learn better if school starts at 7:30 or 9? So after the change in time, what do you guys think? Would students in elementary schools learn better if they had a chance to have a morning snack? So these are just some of the answers of the questions that you would take a look at or all right, so let's just take a look. Okay, so let's just take a look quickly at the distinction between a population and a sample. So it's very basic statistics, but it's really important that you understand the difference. So the population in a statistical study is the entire group of individuals about which we want information. It doesn't necessarily have to be all of the individuals. Okay, so just a few tips about sample versus population. Remember, the population is the group of individuals that we want to know about. Sometimes we'll call it the population of interest. It's not the whole world, it's not the whole United States. You get to define the population. It's the whole group of individuals that we want to find out about. It does not mean that this is the population that we can make inferences about. Okay, so just be careful with that. It's not the population that we can make inferences about. So what does that really mean? So for example, if there were individuals that were not eligible for the sample, then we cannot include them as part of our population and we cannot make inferences about them. So for example, if we were talking about all right, so take a look at the sampling situations. What I'd like you to do is identify exactly as possible the population, state what kind of individuals the population consists of, and which individuals fall in the population. If the information is not complete, complete the description of the population. So you're looking at these, reading them, and identifying the population. So just take a minute, press the pause button, try them, and then take a look at the answers on the next slide. See how you did. All right, so the first one, the population for the Gallup poll was all of the United States adult residents. What was the sample? The sample was the 1,500 residents who actually respond to the survey. In letter B, the population was all of the households in the United States. The sample was those who responded to the survey that was actually sent out. And the population in the last one was all the voltage regulators from the supplier, and the sample was just the 5 regulators that went out to be tested. Okay, so just getting used to figuring out what's your population, defining what your population is, and then figuring out what's a good way to collect the sample from the population. County. All right, so what do we need surveys for? Okay, why do we use them in real life? So number 1 is consumer confidence. That's actually a really good example. So just take a minute and read this. Population. Okay, so what exactly is bias in sampling? So biases in sampling is whenever we design a sampling method, it shows bias if it systematically favors certain outcomes. So the goal when you create is going to underestimate of our own, because in New York City people are it's very expensive and they're really often transparency. So to me it seems to every it's going to favor certain outcomes like little cars and the patient. So here's three tests on overestimate or underestimate. So you can say whether an over or rest. So do bias sampling. Most of the for instance, so actually alone. The way samples the entire so it's fully relevant. However, the estimates will choose small half the time, short half the time, which we are going to balance each other out. So when part of that sample is going to be good rotation, and then within that there's going to be one little bit of lower imbalance in that middle. If the result of that study can see the truth, consistently overestimate or underestimate without. Okay, so how do we sample badly? So let's talk about how we sample badly first so that we can sample correctly. So how do we choose a sample that we can trust in order to represent the population? There's a number of different methods to select samples. Okay, so here's the first one. Choosing individuals who are easiest to reach results in a convenient sample. They're very easy to reach. So if we wanted to do a sample of everybody in Tyson's, in Fairfax County, that was, and talk about how much money they spend on a Friday shopping. If we stood outside of Tyson's Mall, outside of the Nordstrom at Tyson's Mall, and asked everybody coming out of there how much money they spent, that's a convenient sample. Those people are very easy to reach. That's most likely going to overestimate the amount of money that people spend on a Friday because we specifically looked at people at the mall. Okay, so the convenient samples, they are usually underrepresentation of the data. Why? Because they're not good accurate representation. It's too easy. It's too easy to stand in front of Nordstrom and ask the people coming out of Nordstrom how much money they spent on that Friday. So it's not going to be a good representation of everybody in Fairfax County. Okay? So what exactly is convenient sampling? So let's say we want to study the study habits of everyone in your school. So you go to the library and you ask 30 students how many hours of homework they do a week. What's this going to do? What kind of bias is this going to produce? This will overestimate the average homework time spent on the population because I'm only asking people in the library who are most likely the people that are going to be studying a lot. Let's say we want to know how many students at our college campus play intramural sports. So you stand outside the gym and ask 25 students if they participate in intramural sports. What's this going to do? This is going to overestimate the average number of students that play intramural sports because you're asking people as they're walking out of the gym. What about the rest of the campus? Finally, we want to estimate the percentage of students that bike to school. You stand in the parking lot and ask how many people bike to school. Well, if you're standing in the parking lot, all of those people are driving. So this is going to underestimate the average number of students that bike to school because we're only asking people that have driven. So just notice in all of these examples that we're talking about overestimating or underestimating the average number of students that play intramural sports, time spent on homework, or average number of students that bike to school. The example do the following things. Number one, to identify with this interval, out how many students introvert. You just that below this is convenience sample strategy. All the introvert. Next, these are submit requests. This is because we're sampling coming out of the college. Okay, another example. Explain how your college assets this sample to estimate the percentage of students by school versus the college. So, and if you're explaining how the result, I need to make you explain the relative design and how we do those are. Now, this is huge change of that program. Alright, the first example we talked about was a convenient sample. They were almost always guaranteed to show a bias. They're just convenient. Think about this. They're too show keep that in mind. Alright, so in this example, just identify the type of sampling method that was used. Alright, so think about the ones that we've talked about, so convenient sampling or voluntary response, and then explain how this method Okay, what else can go wrong? Bad sampling can lead to bias. All right, so that means we're either overestimating or underestimating consistently using our sampling method. We can help to avoid bias by using an SRS. So you're going to get used to that. SRS is specifically for a simple random sample. Cannot be used for abbreviation for anything else. However, there are two other problems that can be difficult to avoid. What's the first one? The first one is undercoverage. This happens when some members of the population cannot be chosen in a sample. So this is often true no matter how excellent your sampling methods are. There's usually somebody that cannot be chosen in a sample, or somebody that can't be reached. I can't reach them by phone. They're homeless. I can't reach them via internet. They don't have the internet. Okay, so there's usually somebody that's not going to be represented. Almost all samples have some sort of undercoverage. If you conduct a survey by landline, it's going to miss everyone with a cell phone and all the households without a landline. Can you think of some other forms of undercoverage? Just think about how if you were going to take a sample, what are some possible forms of undercoverage? If we did all of the students in Fairfax County and we just took samples in the high schools, what about the students that are either working online? What about the students that are being homeschooled? What about the students that are attending private schools over Fairfax County public schools? If we're taking a sample of households, how can this have undercoverage? Okay, so if we were taking a sample of households to see the average number of people in the house, we'd miss it. All right, the second one is non-response. So this is when an individual chosen for the sample can't be contacted. Okay. And then what's the last thing that can go wrong? Response bias. So this occurs when people give inaccurate answers to surveys. The issue are looking at the go to the doctor, ask how many tests you were and your amount of fraud you're taking in the last month. Remember, how many plus are you? What usual life year do you want to make it seem like you were bar? How many last time you please or do you beat under ones you said? Or you're going to death off boss or like life strength their concern your teeth. Okay, so each of the following on the same survey. When the sample is chosen, you cannot be contacted by calls. You choose to be working on YouTube. They or makers just play for money and then we'll put into the actual question. So in what is a bias? The action explain how the point of result and bias to expression of it. We'll go to the next slide to see the answers. Okay, so here's where the answers. So letter A was undercoverage because people without a phone would not be represented in this situation. Letter B was non-response. Those people physically could not be contacted. C was undercoverage. It's a convenience sample. Anyone not walking down the sidewalk is not going to have an opportunity to answer. And letter D, by making it sound as if they are not a problem in the landfill, this question will result in fewer people suggesting that we should ban disposable diapers. The proportion who would say yes to the survey is likely to be smaller than the proportion who would say yes to a more fairly worded question. Okay, so just be thinking of those types of bias as you're designing sample surveys. So how do we avoid badly worded questions? So if you could just take a minute, click on the link below, this link right here. This will give you a couple of surveys and some badly worded questions. So there are 5 common survey mistakes that will ruin your data. So if you want to collect data so that it actually has a meaningful use for the population, the way that you word your questions have to be correct. If not, it gives an inaccurate representation of the population. Okay, so now we've talked about how to sample poorly. How do we sample well? A key is random sampling. So get that word random in your head right now because we're going to be using it over and over and over again. The statistician's remedy is to allow impersonal chance to choose the sample. A sample chosen by chance, rather than a convenient sample, rules out both favoritism by the sampler and self-selection by the by the respondents. So when we use a random sampling method, it's not people who are just answering, so that voluntary response sample, people who refuse to answer, that non-response, or it is not a convenient sample. So we're trying to get rid of bias by the sampler, for example, doing convenient sample, and self-selection, for example, voluntary response sampling. So what is random sampling? It is basic to statistics. Random sampling is the use of chance to selective sample. It is central in the principle of statistics sampling. So everything is happening by chance and random sampling rather than you, as the sampler, choosing who you want to be part of your sample. Okay, so what exactly is a simple random sample? A simple random sample, SRS, consists of size n, so that's the number of people you're sampling, consists of n individuals from the population, chosen in sizes that every set of n individuals has equal chance to be in the sample. Actually, so n individual has an equal chance. So let's say there are people in the class, and I'm going to take a simple random sample of 2 of every possible combination of 2 out of those 10 people has an equal likely chance of being selected. This is often in practice. People use a random parameter or calculator tools. If we don't have time, you can determine this and look at unit 3 and 4. So what's the basic idea of a simple random sample? Number 1, every individual has an equal chance of being selected. So out of our group of 10, if we're choosing 2, and group 2 has a chance of selection. Every individual is independent of each other, and so has a good enough population. It does not to be a simple random because of chance of being a simple random sample. If you do it, that would not have a random is the percentage of the chance of not having that person simple. Okay, what exactly is simple random sample not? The key with a simple random sample is that every group of size n individuals has an equal chance of being selected. So every group of 2 has an equal chance of being selected out of those 10. So here is an example of not a simple random sample. So just take a second, read this, and see if you can figure out why it's not a simple random sample. Okay, why was it not a simple random sample? We wanted 6 students to be in our sample. Okay, so what exactly is the best way to get a simple random sample? The best way to get a simple random sample is called the hat method. All right, it's like a hat trick. It works well. This ensures that everyone has an equal chance of being selected. So basically what the hat method is you take all of your numbers or your people, you put them in a hat, shake your hat up, and pick, say, 6 people out. So how do we write that so it can be clearly communicated to those reading how we're going to conduct or find our simple random sample? All right, so we're going to write all 20 names of the students on identical pieces of paper, put them in a hat, mix it well, pull out slips of paper until we have 10. Alternatively, I could label or number everyone in the class 01, notice that 01 to 20, put 20 numbers on identical pieces of paper, put them in a hat, mix it well, then pull out the slips of paper until you have 10. Now there are some key words in this section. Number 1, you have to state identical pieces of paper. Okay, because if they're not identical, then it changes the chance of them being chosen. Put them in a hat. Mix it well, because if the last person that you put in is on top, they're going to have a better chance of being chosen. And then pull out the slips of paper so you have 10. So identical, put it in the hat, mix it well. What if you don't have a hat handy available, but you have your handy graphing calculator? So how can we choose a simple random sample using a Let's just take a look at an example. Okay, so before we take a look at an example, let's just take a few tips for describing a simple random sample in the AP exam. 1. Describe your assigned numbers. Make sure you state 0, 1 through 10. Those are each 2 digits, or 0 through 9. Those are each 1. Don't say 1 through 10 because 1 through 9 is 1 digits, 10 is 2 digits. Don't say 90 to 100 because 90 is 2 digits, 100 is 3 digits. They have to be the same number of digits. Address numbers that will be skipped or discarded. Most likely, we're not going to use the or things for this one. Please make sure the includes sentence. Please make sure you take a look at the calculator section on Blackboard to learn how you calculate table of generate random numbers and n different numbers. You would examine if you trust to do it for 6 or 500 n digits. Notice that all numbers are equal from 1 to 8, so 1 to 20, each have 2 digits. Alright, so let's just take a look at this. The school newspaper is planning an article on family-friendly places to stay over spring break on the Jersey Shore. The editors intended to call 4 randomly chosen hotels to ask about their amenities for families with children. They have an alphabetized list of all 28 hotels in the Jersey City. Before you look at the next slide, see if you can add 4 using integer table. Okay, so how can we find our simple random sample using a random table? So here's what our random table would look like. It's just a string of digits. Here's a description that you would want to write. Below are 28 hotels. We need 2 digits. 4, So what was important about the directions or instructions that you gave? Okay, number 1, the labels of the hotel are the same length, so 01 through 28. Same words on the left-hand side, online. How many digits are we? Digits are we? 4. What was our final? What inches and what was? Alright, so take a look at this one and see if you can come up with a way to select a random sample of 3. So the management company of a local mall wants to survey a random sample of 3 stores to determine the hours they'd like to stay open during the holiday season. So I would like you to find the random integer table on Blackboard, use line 105, and select a sample size. Because remember, it's a statistics. Recording. We're going to go ahead and take a look at answer. Okay, so 1 through 2 digits. 1 from 5 from the neighborhood. They've chosen as various sources of information. We're reading the 10 source 18 and 14. Okay, so what is the basic idea of sampling? It's very straightforward. Take it from the user easy way to be one in the user variable. So there's still of using a little more sample Okay, so one way to get a sample is through stratified random sampling. Alright, so let's just take a look at choosing a sample of high school students in Virginia. First, we're going to choose the strata based on the facts known before the sample is taken. So we're going to do Okay, so what are some other sampling methods? Stratified random sampling can sometimes give us more precise information about a population than an SRS. Both sampling methods are sometimes hard to use when populations are large or spread out over a wide area, so it can cost a lot of money to contact. In that situation, We'd prefer to use a method that selects groups of individuals that are near each other. Okay, so how can we make this even easier for ourselves? Another sampling method is a cluster sample. Okay, so a cluster sample is dividing the population. Okay, so let's take a look at an example. First, you divide the individuals into groups that don't necessarily guys. Okay, so I'd just like you to take a minute and read the Okay, so how could we explain how to select a simple random sample of 88 hotel rooms? Okay, number one, each room gets labeled 001 to 880. Okay, so I'd like you to try this one and see how you do. So taking a look at this example, describe how you use the following sampling methods to select 80 students to complete this survey. Okay, go ahead, take a minute and read the key. If you have questions on it, please let me know. If you need to look at it longer, just go ahead and pause the recording. Okay, so the purpose of a sample is to give us information about the larger population. We need a good sample for a good representation. The process of drawing conclusions about a population on the basis of a sample is called inference, which we've already talked about. So why should we rely on random sampling? Okay. What is exactly the margin of error? The margin of error answers the question, how can we reduce variability and reduce our margin of error? We increase the sample size. So reducing variability is saying that we have a huge range of answers. So if I'm taking a look at the number of students that own calculators in Fairfax County, okay, and I'm getting a simple random sample, if I only take a simple random sample of 5 students, I could have one student that owns 0 calculators and one student that owns 5 different calculators. That is a huge variability. How can we reduce that variability and therefore reduce our margin of error? So the margin of error is kind of like, how close are you to the actual population? How close are you to the actual population, to the number of calculators that the students in Fairfax County own? Well, how can we reduce variability or basically get a better representation of the population? We can increase the sample size. All right, more samples, more sample size, larger sample size reduces our margin of error, gets us the value closer to the population, which means it has less variability. So the range of answers is not going to be quite as large. What else can go wrong? Most sample surveys are affected by errors in addition to sampling variability. So remember that sampling variability just means there's a wide range of answers. Good sampling techniques include the art of reducing all sources of error, which we're going to get into later on. You will never eliminate every source of error, but our goal is to make the sources of error as small as possible. Okay, so this is just a funny comic. Go ahead and take a minute and read it. So this is just some sampling error, and this would be voluntary response because he is voluntary. Okay, so just a quick summary. We took a look at a sample survey that selects a sample from the population of all individuals. Random sampling uses chance. The basic random sampling method is simple random sample. To choose a stratified random sample, divide the population into strata. Choose a separate SRS from each stratum. To choose a cluster sample, divide the population into groups or clusters, and randomly select some of the clusters for your sample. Failure to use random sampling results in bias, so we're either overrepresenting or underrepresenting the population. Voluntary response samples and convenience samples are prone to large bias. Sampling errors come from the act of choosing a sample. Randomly sampling error and undercoverage are common types of error. The most serious errors are non-sampling errors, okay, which come from non-response, response bias, and